let's go ahead and get started. The objectives today, those of you in the class, you should be able to see from your book, section 6.1 and 6.2. So we're going to use the law of sines to solve our oblique triangles, and these are some of the examples. AAS, which means you have an angle, and another side of a triangle given. ASA, an angle, a side, and an angle, and SSA, two sides, and then the angle. We're going to also look at areas of triangles. We're going to use the law of sines to model real-world applications, law of cosines to solve some of our triangles too, as well as modeling real-life applications, and then using Heron's area formula to find the area of triangles. So let's get started with the law of sines and what that is. So we have a triangle ABC, and the sides are little ABC. Then we have this ratio, this relationship. If you take little a, which is side A, divided by the sine of big A, which is the angle A, that is the same relationship as little b over sine B, which is side B over the sine of the angle B. And that's the same as C over sine C, which is the side C over the sine of the angle C. Now remember, we've seen before that the angles all have uppercase letters, right? So in this case, you have ABC, and the side across from it is the lowercase. So here is angle A across this side A, little a. Here is angle B across this side B, little b. So keep that in mind that we have that relationship. So in the past, we were looking at triangles that were right triangles. And when we were solving those triangles, we can use Pythagorean theorem, and we can use our trig function definitions or trig definitions. So now we're looking at triangles that are not 90 degree, that don't have a 90 degree angle, so they are not right triangles. So we have to use something else. So here we have an example of an acute triangle. We can use law of sines. All the angles are acute, which means less than 90. And we can use this for obtuse triangles, where you have at least one angle that is obtuse, which means it's more than 90. And you can see those relationships here as well. And H represents the height of the triangle. No matter wherever you're at, from the base to the tip of the top, that's the height. And here's the example of the height right there. Okay, so in order to use this formula, law of sines, you notice we need a relationship here. So we have to have a pair, capital A and little a, or capital B and little b, or capital C and little c, which means we need to have an angle measure and the measure of the side length across from it in order for this formula to work, okay? So keep that in mind. So the way the formula is presented right here, we can use, and this helps when we want to solve for a side length. So when we're solving for the little a, b, or c, it works to set the formula up this way. But when you want to solve for a angle measure, it works to just flip these, take the reciprocal of all of these, and it's the same. So you have sine A, sine B, sine C on top as the numerator, and the denominators are the lengths, okay? But that works as well. That's also another version of the law of sines, and we can use this when we want to solve for one of the angle measures, okay? Okay, so here we have an example. We're given two angles and a side, so that's why it is AAS, the two angles and then the side next to it. So we have a triangle. C is 102, B is 29 degrees, and little b, the length is 28. We have to find the remaining angles and sides. So here's that picture with the C and the B and the 28 for that B right there. So just like in a previous section, we were solving for triangles, we're doing the same thing. So I'm going to go ahead and list all the values that we have for the triangle, the angles and the side lengths, and then we start by filling in what we have, what is given. B is 29, I put that in. C is 102, I have that. Little b is 28. Okay, so what do we need to do? We need to find angle A, and then we need to find the side lengths A and C. So hopefully you remember again from previous presentations that all the angles of a triangle, all the interior angles of a triangle add up to 180. Now that is always true no matter what type of triangle, 90 degree a right triangle, a acute or an obtuse triangle. So whenever you already have two angles of a triangle, you can easily find the third by subtracting these values from the 180. Okay, so all the angles add up to 180. If I subtract two given ones from the 180, I get the other one. So here I'm going to subtract the 29 and the 102, and I get 49 for the other angle, the A value. Okay. So now notice that I do have given a pair, right? I have an angle measure and I have the length of the side across from it. So that is what helps me, and that is how I know I can use law of sines. Okay. So when I set this up, I'm going to start by finding A. I use just that proportion that I need. I have the B over sine B value. If I'm going to find A, I set that up just equal to the A over sine A. And we're finding side A, so we start with the little a on top. So again, keep in mind, this is the ratio that I have. This is at least what I need to use law of sines. I have to have at least the angle measure and the length of the side across from it, which is what I have. And then I fill in whatever else I have. I'm solving for little a, but I have the angle A measure 49, so I put that in. Now to solve, I can just multiply both sides by this denominator to get the A by itself. So multiply by sine 49 on both sides. It cancels on the right side, and that's how I get A by itself. On the left, I have to multiply all of this to get my A value. So take out your calculators, make sure you're in degree mode because we're working with degrees, and we should get 43.585. Pay attention when you're doing your work how you need to round, sometimes 1, 2, or 3 decimal places. And if we're rounding to 2 decimal places, it should be 43.59. So I just found that A value, okay? So continuing on, now I need to find the C value. So again, I have my law of sines. What am I working with? I don't need all the 3 equations or the fractions. I just need the ones I'm working with. I have the B and sine B values, so that's what I plug in. And I'm going to solve for C, and I have the sine C. So these are the 2 parts of it that I'm using. Again, I have both of these values, 28 and the sine 29, and I go ahead and plug in what else I have, which is the 102 for the big C value, and I'm solving for the little c. Multiplying by 102 on both sides is what I have to do to cancel right here. Leaves me the c by itself. I'm left with all of this, and again, you have to plug all this into your calculator. We're in degrees. When you multiply all of that out, we should get 56.492. Round to 2 decimal places, 56.49. So that is my C value. So here's an example of how we solved a triangle using our law of sines. And again, key is that we had a pair given. We had an angle value and the side length across from it given that we were able to use. Okay, so let's do another example. We're going to use law of sines to solve this triangle here, and it does say round to 2 decimal places. So we always start with, what do we know? Remember, solving a triangle means finding all the angle measures and all the side lengths of the triangle. We have to have some given, so let's plug in what we have. For B, we have 10. For C, we have 135. And then we also have the other C value here of 45. Okay. So we need to find angle A and then the side measures for A and B. So again, when you have at least 2 angles already, it's easy to find the third. All 3 should add up to 180. So if I subtract the other values that I have, the 10 and the 135, I get the remaining value, which is the 35 for A. So we got that one done. Okay, so now, because I have this pair here, again, I have the big C, which is the angle value for C, and I have the little c, which is the length of the side across from that angle. I can set up law of sines using this proportion. So I'm going to find that A. I need to find A and B, but I'm going to go ahead and find A first. So I plug in the pair that I already have right here. I have the value for C, and I have the value for big C, so it's sine of 135. And I'm going to find A first, so I set up that pair. I don't know the side length, little a, but I do know the angle measure is 35, so I plug that in. Solving makes it easy when the variable that we want is on top. You just multiply by what you have on the bottom. So both sides get multiplied by sine 35. It cancels on the right. So I am left with a, and I need to multiply all of this to give me the value of a, little a. And it should give 36.502 when you round, 36.50 rounded to 2 decimal places. And there we go, we have that value, okay? So now we're going to do it again. I just need the b, the next side length. My setup is going to be the same to start. This is the values that we already have. And I plug in the other values that I have. I need to know the length b, but I know the angle measure, which is 10. I plug that in. And just like the others, multiply by that denominator to get b by itself. It cancels on the right. B is by itself. I multiplied by sine 10 on the other side. So I have to multiply all of this. And for B, I should get 11.05. And that is how this triangle is solved. Okay, again, using the law of sines. Okay, here's another example. We're going to be given two angles and a side. The side is in between, so the way it's written is how we have it in the problem as well. So we have an angle, we have the side, and then we have another angle. Okay, so word problem here. A pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. So we actually have a figure here. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. Angle of elevation right here from that tip of the shadow up to the pole, that makes that angle 43 degrees. How tall is the pole? So that's this value right here, okay? So we got to set this up. We don't need all the values, but I'm going to set it up as if we do need all the values just to kind of help us figure out what we have, right? So again, what do we have? I have angle A, which is right here, 43 degrees. I have the length C, which is down here, which is 22 feet. And I also have, so the actual triangle that I have is this one with A, and then this is length C, and this is length B. So it does tell you that this, the tilt is 8 degrees, right? Well, if we had that right angle right here, that's 90, and then it tilts 8 degrees beyond that. So then that means that that angle B right there is actually 98 degrees. So we have the 90 plus that 8-degree tilt. So this measure is 98 degrees. So that's how we have that, and we have that B value, okay? So let's start by finding the C, because remember I said once you have the two angle measures, you can easily find the third measure, because these should all add up to 180. So now that C value comes from 180 minus the other two angle values, minus 43 and 98. So that gives me 39. So now I have the C value. Okay, so now guess what? I have a pair. I have an angle measure, and I have the length of the side across from it. So again, that's my key that I can use the law of sines with this setup here. So I'm going to use my C over sine C, and now I want side A. So remember, they're only asking for the length of this pole. So I can use my law of sines equal to A over sine A, fill in what I have. Again, this is what was given. This is the pair that's given. I have the angle measure, 43, so I plug that in. And just like the previous ones, I multiply by that denominator to get A by itself. And I have to multiply all of this on the left to give me the value. So that gives 23.8415 if we round 23.84. So this one is only asking for that. I did the setup so I don't have to finish it and find B, because that's all I needed was the height of the pole. So if we round, that is 23.84 feet for this one. Okay, so this is called the ambiguous case. So again, depending on what you're given, sides or angle measures, that's how all these letters come from, right? SSA, ASA, whatever we have. So when you have this case, when you have two sides at an angle, right, two sides next to each other, we got to consider more possible options. So they present it like this, but the way I remember the ambiguous case is actually by looking at it the other way around. You have an angle and then the two sides next to it. So that, if you read it that way, the angle and then the two sides, that word helps me remember, like, oh, this is the one we have to like think about and look twice at, right? So when you have that case, you have different possibilities that you got to consider for your triangle, okay? So we have different examples here. We have a few where A is an acute angle. So if you're given that angle A, that's an angle measure and it's acute, we're looking at these options right here, what we can have for A. And you set it up, you have to either compare A and B or sometimes H, that height, okay? If A is obtuse, bigger than 90, we have these options we have to look at, right? So what we're doing is we're comparing A sometimes with B or sometimes with H to determine the number of possible triangles. H, we find the height by taking B times sine A. So for example, let's say we have the A value, we find the H value. If H is bigger than A, that means we're not going to be able to make a triangle with what's given, and so there's going to be no solution or no triangle possible, okay? When A is acute and A is equal H, or if A is bigger than or equal to B, then we're going to have a triangle that we can do. Just like the previous ones, we'll be able to get a triangle and find all the values that we need. When A is acute, but A is bigger than H and then B is bigger than A, we're going to have two triangles. So we're going to have to do the problem 2 times because there would be 2 possible triangles that I can make with the given information. When A is obtuse and B happens to be bigger than or equal to A, there's also going to be no solution, no triangle. Or if A is bigger than B, we're going to have 1 triangle. So again, this case, I like to say that ASS, the other way around, that's the one where we got to go, uh-oh, we have options. We got to look at what we're going to do here, okay? So again, don't forget that the way we find that H value is B times the sine of the A, the angle. Okay, so let's do an example of this right here. We have to find, it's asking us to, well, sometimes it's going to ask you to find the triangles, okay? But just know sometimes there's no solution or more than 1 triangle. So in this case, there's going to be no triangle, but let's look at how that happens and let's look at the values we have. We're given A, we're given a B, and then we're given the angle A as well. So we have an angle and the 2 sides right next to it, right? So we got to compare, like with the information on the previous slide, based on whether or not the given angle is acute or obtuse. Again, acute means less than 90, obtuse is greater than 90. If it was 90, we'd be doing this a different way. So here, A is acute, less than 90, so we're going to compare A with B and with H. So I recall from the previous slide that when A is acute, less than 90, these are my options for a triangle. So I got to compare the values of A and H, sometimes with A and B, to see what I got, okay? Well, I have little a and I have little b, so I know that B, 25, is bigger than A, the 15. So it can't be this one, because for this case, A would have to be bigger than or equal to B for me to have the 1 triangle, but I don't. B is bigger, so it's not that case. The other cases involve what is H. So I have to now find the H value so I can compare my A value here with H. So let's find H. H is B times the sine of A. So let me plug in those values. My B is 25. My A is 85, big A, my angle measure. Taking this into your calculator, H is 24.904. So that means that this number 24 is bigger than my A over here, right? A is 15, H is 24.9. So that matches, or not equal, A isn't bigger, it matches this one right here, that H is bigger than A. So then what does that mean? That I can't make a triangle. So if I try to work this out, it's not going to work. I get no solution, okay? So we can look at this and see that we're, because values we get match this triangle, it's not going to work. There isn't going to be other values we can get to get a triangle there. So that's why this one is no solution, okay? So let's try another one. It's asking us to solve, if possible, the triangle, okay? If there's more than one solution, you got to find both. So again, what happens here? What do we have? A, I have the A value, angle value. I have little a, the side length, and I have B also, okay? Again, it's the angle and the two sides, ASS. So I'm going to do what I did before. I'm going to look at what I had from a few slides ago. This time, though, A is greater than 90. So it's an obtuse angle. So I'm looking at the options for when A is obtuse. I have to look at what B is and compare A with B. Okay. My A value here, little a is 125. My B value here, little b is 200. And what is that? That's this case right here where B is bigger than A, right? So then what does that mean? Again, it matches with this option right here. So again, there's going to be no solution, okay? We got to keep that in mind, all right? Another thing that I want you guys to keep in mind that helps is the biggest angle has to be across from the biggest side length, okay? If A is obtuse, the other angles have to be smaller, have to be acute. So if A is obtuse, that's going to be the biggest angle, okay? So this A, 110, is going to be the biggest angle of my triangle. So that means that the side length, little a, has to be the biggest length, okay? That's just the way it works for the triangles. So right away, I kind of keep that in mind right away, and that's why this works. A is 125, B is bigger. That can't happen. You see, you have the triangle here. It's not going to work. You're not going to be able to draw that rest of that triangle because A is too small. So the biggest angle of the triangle has to be across from the biggest side length. So if A is the biggest angle, little a has to be the biggest side length for a triangle. So you can keep that in mind. That helps me out with these as well. Okay, so that just looking at that too could have told me no solution as well. Okay, another case, the angle and two sides. Let's see what we have here. We're going to find two triangles when little a is 12, little b is 31, and angle A is 20.5. So let me plug those in. And again, you see it's the same case. We have the angle measure and the two sides next to it. Okay, now I'm going to go back to, like I did a few slides ago, and see what I have here, what kind of triangle I'm going to get. So because A is acute, again, smaller than 90, these are my options that I'm looking at, okay? So we got to compare these values with B or with H as well, okay? A is 12, B is 31. B is bigger. So in this case, when we compare A and B, it's one triangle when A is bigger. So that one's not going to work just by looking at my A and B values, okay? For the other ones, I need to know my H value in order to compare. So I'm going to go ahead and find H, which is B times sine A. So B is 31, angle A is 20.5, evaluate there, and H is 10.856. So let's look at that. If H is 10, little a is 12, it can't be this triangle because H is not bigger than A, okay? It can't be this option because H is not equal to A, right? What we have here is that A is bigger than H, and then B is even bigger than A, so it matches this triangle right here. So that tells us that based on what we were given, the angle and these two side lengths, we look at the fact that there's going to be two possible triangles that could be made, right? So there's going to be different values that I can get for B and C and little c. So I'm going to be able to make two triangles, okay? So we know that, so we know we're looking for two different values, okay? So first, we're going to have to start with, and I put subscript 1, B1, C1, and little c1, because that's going to be the values for that first triangle that are possible, and then we're going to look at the values for the second triangle that are possible. Okay, so we know we need to get two triangles. Okay, we're going to start like we've been doing all of them. Okay, we know here that we have a ratio. Perfect. We can use that for our law of sines. And we have a little b value, so I'm just going to be able to solve for that angle b value, right? So now this one, we haven't done one like this, but when I'm solving for the angle, it works better to use the reciprocal for my law of sines. So I'm going to start with sine A over little a equals sine B over little b, okay? Let me plug those values in. Again, here's my pair that I have. So I'm able to plug that in right here by 20.5 and 12. And again, because I'm solving for the big B, that's the variable that goes in the numerator. So again, how do I solve? Like all the previous ones, multiply by that denominator, in this case times 31 on both sides. Cancels the 31, you have 31 over here, so now I have sine of B. And hopefully you recall, now we want to get B by itself. It's the angle, but it's sine B. So I do that by taking the inverse sine, or the arc sine of both sides, okay? So on the right, the arc sine of sine cancels and gives me just the B. On the left, I have to take the arc sine of all that I have here. So now again, you need to be able to put all this in your calculator, okay? Practice. Go to tutoring even for calculator help. I know a lot of times just typing all this in properly to the calculator takes some practice and some work, so keep that in mind. But plugging all of this properly into the calculator should give us 64.783, and that is our B value, okay? So continuing on with this triangle, now we can find C. Again, I hope you guys are seeing a lot of the similarities or the patterns with these. Once we have two angles of a triangle, we can find the third by subtracting the two given angles from 180. So I'm going to start with that. 180 minus my A and B value, minus 20.5 and 64.78 gives me my C value, my angle, my last angle that I need, right? Okay, continuing on, I need my little c. I'm going to work it the same as before, law of sines. Now this time I wrote the other version, right? Because the variable that I want is little c, so that goes in the numerator what we're solving for. Plug in what we have. I have that A ratio. I plug that in. I have angle C, 94.72. Continuing on with the pattern, multiply by the sine of 94.72 on both sides to cancel on this side. And I have to multiply it on the other side. So properly putting all that into your calculator should give you 34.15 when we round for the C value. So there we go. We solved for the triangle. Now, however, we knew in the beginning that we were going to have two triangles. So if you didn't know that, you might think, okay, well, I'm done. I solved. But we know there's two possibilities. So how do we start to get the second triangle? Well, when we know there's a second triangle, from the beginning, when you get one of those angles, you're going to take 180 minus that angle, which gives you another angle that's going to work to make another triangle. So now I want to start with my other triangle. So I'm going to take 180 minus that first B value that I found. 180 minus this 64.78, if I round, I get 115.22. So it is possible for me to have another triangle with the original given values. I can get another triangle if I have another value of angle of 115.22. So I'm going to work on that one next. Okay, so same one, same values, but now my B2 is 115.22. So here are the previous values I already found. That was my first triangle. Now I'm going to fill in the values to help me get my second triangle. So the original values are the same, the given values, my A, my little a, and my B, correct? And then I showed you guys how we found that other angle, right? When we first solved for our first angle in the previous slide, just minus that from 180. So that's my B. So now I continue on to find the other values, okay? So this is my new triangle. Again, I have two angle values, real easy to find the third. So my C in this case is 180 minus the other two angle values. Subtract those values, and for this C, or C sub 2, the second C of my triangle is going to be 44.2. 28. So all I have left is to find that little c, or that side length, okay? So we can set it up like we did before. We have that same ratio that we can use, a over sine a. So I plug those values in, the 12 for that little a and the 20.5 for the sine a. I'm solving for little c, so that's on top. I plug in the sine of the angle, 44.28. Like usual, multiply by that on both sides. So c comes from all of this right here, which should be about 23.92 when we round. Okay, so here's an example of the values that were given originally work so that there's two triangles possible. I showed you guys how to check that case, right? The ambiguous case, we're checking based on the value of A, whether it's acute or obtuse, what type of triangles are possible. Sometimes none, sometimes one, but in this case, two triangles were possible based on our values. So knowing that, you work it twice. You work to find all the values of one triangle, which we did, and then you work it again to get other values that are also possible to make another triangle from those original values. So that's pretty cool that we can do that, but just keep that in mind when you're going to have to do that, okay? Okay, so area of triangles. Now there's different formulas to find the area of a triangle. The most common one, the one I remember, is 1/2 times base times height. But we're going to present different formulas to find area. They all work. It is just going to be a matter of what is given or what you can get, okay? So for this formula, the area here is 1/2 of the product of the lengths of two sides times the sine of the angle in between. So that is, area is 1/2. If you have a little b and little c value, and you know the angle in between, sine A, we can plug that in and get the area. So it's just depending on what you have. If you have A and B, then you would also need angle C, and you can plug that in. If you have A and C, the side lengths, and you would also need angle B to plug that in. So just based on what you're given, this formula is, again, to plug in two side lengths and the angle in between them, and that's how we can find the area, okay? So let's do an example here. Find the area of a triangular lot with the side lengths of 90 and 52 and the included angle of 102. So look at this picture right here. If I label A as 90 and B as 52, the included angle in between 102 is the C, because across from that would be that length C, okay? So this is our setup, okay? This works to plug it into our formula for area. So we're going to use 1/2 times the lengths A and B times the sine of that angle C. So 1/2, A is 90, B is 52, C is 102. So just properly plug everything in, and then you type it all into your calculator. 1/2 times 90 times 52 times the sine of 102. And you should get 2288.86. Be careful to how they want you to round. If they want you to round to the nearest whole number, then this one would round to 2289. So the area for this one would be 2289. Okay, so continuing on, find the area of this triangle, round to one decimal place. So this is 54 degrees and 30 minutes. So we first have to convert the 30 minutes to degrees, the way it's presented, okay? We have little a and b, but we can't work with that. We have to convert it. So remember, this is 1 minute. 1 minute is 1/60 times the degree value. 1 second looks like this, with two little, looks like apostrophes there. It's 1/3600 times the degree, 1 degree, right? So for this one, we have to take 30/60 to convert that to degrees, 30 over 60 is 0.5 or 1/2. So 54 plus that would be 54.5. So we have to use that value, not the way it was presented, we convert. So now we can find the area, just plug everything in. We have the A, we have the C, and we have our B, our angle measure. We can plug that in. Again, appropriately put all that in your calculator, and it's set to round to 1 decimal place, so it's 0.3 when we round. So that's the area formula using those values that were given here. All right, so now we have a few examples. Now we're going to look at the law of cosines. So here's the law of cosines. They're all the same. They are just rewritten based on what you have, an A, a B, or a C. Okay, but it's all the same, just again rearranged for that angle or side length that you have, right? Okay, the way these are presented, it has the side length solved for. So these are going to work when you want to find a side length. To go even further, if I want to solve for the little a, b, or c, I can take the square root of both sides. Okay, so I can take the square root of all of these, and little a is going to equal to the square root of all of this. Little b is going to equal to the square root of all that. And little c is equal to the square root of all that. You would appropriately plug in the values, side lengths for b and c, and then the cosine of angle A. These forms of the law of cosines, again, same thing, they just solve for the angle measure. These are going to work when you want to find an angle measure, when you're solving for an angle measure. So again, to go even further, this is, for example, cosine A of all this. If I wanted to get A by itself, remember, I would need to take inverse cosine of both sides. So if I take inverse cosine of both sides, I solve for A. So then A is the inverse cosine of all this right here. B is for inverse cosine of all that, as well as C. So you would appropriately plug in the little b, little c, little a values over here, take the inverse cosine, and that's how you would solve for one of these angle measures. Okay, so keep that in mind. You have your versions for law of cosines, solving for one of the side lengths or solving for one of the angles first. Okay, so how are you going to know if you're going to use law of sines or cosines? Well, it depends on what's given. Remember, for law of sines, you need a pair. You need an angle measure and you need a side length to have that ratio complete, and you can set it equal to another ratio. If you don't have that, we got to consider law of cosines. So for this one, I am just given the 3 side lengths. I have no pair, so I cannot use law of sines. So we use law of cosines, okay? So I need to solve for one of these angle measures. So I'm going to solve for A first. Now, if you recall from the previous slide, this would be the formula. It's the inverse cosine of all this. So I'm going to take my values A, B, and C, and I'm going to plug them in to give me my angle A value. So here I plug in B is 19, C is 14, A is 8, all over 2 times B and C, plug all of that in. I get 493 over 532. Inverse cosine of that gives me my A value, 22.08 when I round. So that's an example of how we're using the law of cosines. I had all side lengths. I find an angle measure, my first angle measure. Now I'm going to use it again. I'm going to plug in all these side lengths to find angle B. So I switch the formula to B, very similar, but you're plugging in the lengths in different order. So I appropriately plug in my A, C, and minus B value, all over 2 times A and C. I get negative 101 on top, 224 on bottom. Inverse cosine of that should be 116.8 when I round. And there's my B value. So here's using law of cosines. To find angle measures, I was given all 3 angles. Now, I actually could do law of cosines again. I could solve and find C. However, remember, once we already have 2 angle measures of the triangle, we can easily find the third by just subtracting these from 180. So again, law of cosines would work again to find C, but now I'm just going to subtract the A and B values from 180 that I already have, and I get my C value, my remaining value. So from the beginning, I started with finding angle A. You honestly could have started with finding any of the angles using the law of cosines, right? So I could have found angle C first and then B and then later. So either of these angles could have been found with law of cosines, okay? Okay. Another one. So we have two sides in their included angle. Find the remaining angles. What's left? Okay, so we can solve the triangle. Again, the procedure that you're going to use when you're solving a triangle. If it's a right triangle, we've done those before, you can use Pythagorean theorem and your trig definitions. If it's not a right triangle, we're looking at law of sines or law of cosines, right? All right, well, let's see what we got. We have angle A, we have side B, and we have side C. Now, if we had a pair, sorry. If we had an angle and its side lengths, we can do law of cosines. But we don't have that, so that's when we know we can go with law of sines, okay? I'm sorry, law of cosines, okay. If we had an angle pair, we use law of sines, sorry. If we don't have that, we don't have a pair, that's when we're looking for law of cosines. Okay, so I'm going to start with law of cosines, okay? And I'm going to start with my little a value right here, okay? So I'm going to solve for that little a. And again, just make sure you have everything appropriately plugged in. Little a requires me to plug in B and C and the angle A. Those are the values that I have. I plug all that in appropriately. Get square root of 29.237518. So once I take the square root of that, I should get 5.40717. So I'm going to leave this rounded to 4 decimal places for A. Again, always double check how they want you to round, but it doesn't hurt in the beginning if we're going to use this value again to take it out as many decimal places as possible so that you are more accurate with your answers. So 4 decimal places for this one. A is 5.4072. Okay. So now I have 3 side lengths, but I also now have an angle, a pair, an angle and the length of the side across from it. So at this point, I can use law of sines. I can continue with law of cosines. I have all the 3 side lengths and I can do solving for B. But again, I kind of like law of cosines. So keep that in mind. Once we have a degree and the side length across from that, you can resort back to law of sines. Or like I said, we can continue how we previously did and solve for B using law of cosines. So you have options. You just need to know what you're given and what you can use, okay? So plugging all this in appropriately, because I'm solving for an angle measure B, that goes in my numerator. This is the pair that I had. Always multiply now by the denominator to cancel. Gives me sine B times 9 over here, right? Now remember, we got to do inverse sine on both sides. Inverse sine gives me B by itself. Take the inverse sine or arc sine of all of this. Appropriately plugging this into your calculator, we should get a B value of 44.7025 or 0.70 for rounding. Again, like we said, you can do law of sines again to solve for C. We can do law of cosines again to solve for C. But I have 2 angle measures, and I think that's just the easiest. You just minus that from 180, and my C is 110. Okay, you can always do it again to check your work using another method. Okay, but there's the example, and again, this one we use law of cosines and law of sines to work this one, okay? Okay, here's another one, law of cosines. Because we have we have the C105, we have little a, 9, and we have B. We don't have a pair, so we can't use law of sines, okay? So the way I set this one up, we're going to start with finding side C. So I plug everything else that I have. I have A, B, and angle C. Appropriately plugging everything in, taking the square root of everything inside, I get 11.05505 which rounds to 11.06. Side length C is 11.06. Okay, so again, now we have options. We have all the three sides. We can use law of cosines to find another angle, which I'm going to go ahead and do here. But last time I used law of sines because once I have a pair, I have the angle and the side length, I can use law of sines with that pair to find some of the rest. So again, I'm just giving you options. So this time I'm going to use law of cosines to solve for another one of these angle measures. Okay, so I'm going to solve for A. If you recall from the formula from a few slides, we have the inverse cosine of all of this, which is A. So be very careful, appropriately plug everything in. Little b is 4.5, c is 11.06, a is 9, 2 times b times c. Careful with the calculator, so appropriately plugging all of that in. So taking it a step at a time, it'd be inverse cosine of this right here. Taking that value, it's inverse cosine of that. And we get a is 51.79. So depending on your calculator, how you want to do it, just plug it all in or do it step at a time. Just be very careful, check your work. So A should be the 51.79. So again, you can do the same process to find angle B. You would use law of cosines to solve for angle B. We have options as well. We can use law of sines. But how I've been doing it all previous ones, once I have two angle measures, subtract them from 180 and we get the remaining, the 23.21. Okay. All right, so I hope you guys are getting the hang of it using law of sines, law of cosines. That was the last of those examples. But we have one more example, which is another area formula. This is Heron's area formula. So again, you're going to have like your tool of area formulas. Depending on what is given in the problem is how you choose the formula. So I told you the basic area formula that I remember is 1/2 times base times height. So if you have a base and a height measure for your triangle, you can do that area. Previously, we did where you need two side lengths and an angle measure. You plug that in. Now this area formula for a triangle involves just knowing the three side lengths. So when you have those three side lengths, A, B, and C, we use Heron's area formula, and here it is. It's going to be the square root of S times S minus A, one of the side lengths, times S minus B, the other side length, times S minus C, the other side length. So what is what is S? S comes from you add the three side lengths, A plus B plus C, and divide by 2. So we use the three side lengths. We don't need an angle measure. We just need all three side lengths of the triangle. We plug them in and we get the area this way. Okay, so we're going to use the area formula here to find the area of a triangle with lengths 43, 53, and 72. Okay, first we're going to find S, plug everything in appropriately. My A, B, and C values, 43, 53, 72 all over 2, which is 84. 168 over 2 is 84. So that's my S value. So now I can plug everything into this formula, my area. Here's the formula again, and here's everything. S is 84. Then you're going to do 84 times my A value, 84 times the other side length B, and then 84 times C. Order operations, subtract everything in parentheses, and then I multiply everything. It is the area of all that, square root of everything under there, and I get 1131.8869. So depending on how they want you to round, if we round here 2 decimal places, we get 1131.89 for the area. So that is pretty cool. We can find the area of a triangle with different formulas, different ways, just again depending on what is given. And that is going to be the same case when we are solving a triangle. Depending on the type of triangle you have and what is given, you have options for solving a triangle as well. In this section, it was law of sines and cosines that we used to solve a triangle. questions. If anybody has questions, let me know. Otherwise, that would be the presentation for today.
Thank you, Ms. Camarillo. Thank you, everyone, for joining us today. But before I let you go, I'd like to invite you to the sessions later on. So today at 1 p.m. for student success topics, we'll be going over the Opportunity High School with Chef Gira and Carmen Gomez. Next week, we'll be back again with Happy Math Hour on March 6th at 11 a.m. We will be having for Math 1332, it'll be numeration systems, place value systems, and base systems. For Math 2412, we'll be going over vectors. Then in our 1 o'clock session, we'll be having our special guests of the Center of Students with Disabilities and the Writing Center. Thank you all for joining us today. We hope to see you again for Happy Math Hour.